All right, this factoring video is section 6.5.2, and we're going to continue along our path where we ask, is there a GCF? And there is a two-term or binomial to factor. Last lesson was about the difference of two squares. Now we're going to look at, and this video covers both of these. These really are linked together. This is the difference of two cubes, and this is the sum of two cubes. Now, I'm going to go off to our lesson for 6.5.2 and talk about exactly what cubes are and what the pattern is. But the sum or the difference of cubes, the pattern is very, very similar. So let's take a look. Let's talk about cubes first. 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 is 4 times 2 is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. Now, I'm not going to build this tremendously large list, but it is good to begin to recognize, and of course any variable to the third power would be considered a cube. Now, the pattern for factoring the sum or the difference of cubes is one that is kind of a challenge to memorize. So I'm going to give you what I hope is a little trick. Suppose that you are asked to factor x to the third minus 125. There's no common factor. It is the difference of a cube minus a cube. All right, when you recognize that, here's the pattern. You start with a binomial, two terms. The other factor is a trinomial, three terms. So it is binomial times trinomial. How do you build the binomial? You take the cube root of this, x. You keep the sign, minus. You take the cube root of this, 5. And you can talk to your instructor about your particular calculator and how you can take cube roots on it if you need the calculator help. Now, this trinomial, I'm going to erase that because I don't know how big I'll need this to be. Here's how you build it. The first term is the square of this. So you square that. Then you always change the sign. Whatever this is, you change the sign. So if this is a plus, this is a minus. If this is a minus, this is a plus. The next position is the product of those. You've already got the sign, so just multiply them without the sign for 5x. And then the last position is the square of that, and that will always be positive. So let me say this. Cube roots. Square, change sign, product, square. Square, change the sign, product, square. Literally, if you will say that about 10 times, you will remember it. Square, change the sign, product, square. If this had been x cubed plus 125 instead, we would have our parentheses, and I leave this one open till I'm through. Cube roots. X, keep the sign plus, cube root of 125 is 5. Now what was that thing I asked you to say 10 times? Square, change the sign, product, square that. if you wanted to check it, you would probably need to use the distributive property, multiply everything by x, then multiply everything by 5. Everything would drop out except those two terms. So it doesn't matter if you're dealing with the difference of cubes or the sum of cubes, the pattern is the same. Let's see how we do. Number 1, it has z cubed plus 125, and I'm sorry I used those numbers in my example. Is there a common factor? No. It's a binomial. Is it squares or is it cubes? It's cubes. So if it's cubes, binomial, and then open the trinomial. Cube root of z cubed, z, plus sign. Cube root of 125, 5. How do I build this? What was that thing I said? Square. Square the first one. Change the sign. Minus. Product. 5z. Square the last one. Plus 25. And I'm done. You might think you can factor this, but this is always finished. It is a prime factor. It is done. You have to put all that in as your answer. All right, let's look at number 2. I have 8x cubed minus 27. Factor it. Is there a common factor? No. It's a binomial. Is it squares or cubes? That's a giveaway. It's cubes. I remember 8 is the cube of 2 and 27 is the cube of 3. So binomial, and open that trinomial. The cube root of that is 2x. Keep the sign. The cube root of that is 3. Now I'm going to use these to make my trinomial. Square the first one. 2x times 2x is 4x squared. Change the sign. Make it a plus. Product. 6x. Square the last one. 9. Close. Done. Those are your factors. If you can remember to take those cube roots, then square, change that sign, product, square. Square, change the sign, product, square. All right, let's look at x cubed plus 125 y cubed. Is there a common factor? No. It is a binomial. Is it squares or cubes? It's cubes. Cubes. Here we go. Cube root of x cubed is x. Keep the plus sign. The cube root of 125 is 5. The cube root of y to the third is y. Use these to help build this. Square, x squared. Change the sign, minus. Product, 5xy. Square the last one, always positive. 5 times 5 is 25, y times y is y squared. All right, let's look at, I think, no, we have a couple more. We have 5x cubed plus 40. Before you do anything else, you're probably looking at that, you see it's a cube and you think, oh my, 5's not a perfect cube. No, it's not. But 5 is a common factor. There's a GCF in this. Always try to be aware of that. So if you factor out the 5, that's going to give us x cubed plus 8. Is this binomial cubes or squares? Well, it's cubes. So I will keep that 5, don't lose it, it's a factor. And because it's cubes, little parentheses and open the big one. Cube root of x cubed is x. Keep the plus sign. Cube root of 8 is 2. Square. Change the sign. Product. Square the 2. Make sure you include all of that as your answer to the factors. Last example, I have 128x cubed minus 2y cubed. And I look at that and I do not recognize 128 or 2 as being in my cube list, but look, there's a common factor. So I factor out the 2. 2 goes in there 64 times, so it's 64x cubed, minus 2 goes in there, canceling that out, and I have minus y cubed. So if you had needed to, you could have put your little 2 up there. Is this new binomial squares or cubes? Well, it's cubes. I can factor that. Small parentheses, open the large one. The cube root of 64 is 4x, keep the sign, minus, cube root of y cubed is y. Now use these to build the trinomial. Square. 4x times 4x is 16x squared. Change the sign, plus. Product. 4xy. Square the last one. And we're done. GCF, and then it was squared. It was the difference of cubes. And it doesn't matter if it's the difference of cubes or the sum of cubes, the words I used were the same. You keep the sign there, square, change that sign, product, square. Okay? Give that a try.